Moving on to the topic now, that is on this is the 11th topic, which deals with measures of central tendencies and measures of dispersion, a very vital topic on statistics, wherein given a set of observation we need to find the central tendencies, orientation, and which is nothing but your central tendencies, and also we need to talk about how the observations are distributed, and also know to what extent from the central tendency the distribution is available in our observations, which is called dispersion. Now moving on to this 11th topic, quants 11, dealing with measures of central tendencies and dispersions. The first question: a measure of central tendency for a set of observation is, based on your definition of central tendency, the answer is option A. That is, going back to our PowerPoint presentation, it is the central location of the observation. So a measure of central tendency for a set of observation is the option A, which says the central location of the observation. Second question: if each of a set of observation is increased by a non-zero constant, then your arithmetic mean is increased by the same constant. This is based on the property of arithmetic mean. Go to your PowerPoint answers, which says C option, arithmetic mean is increased by the same constant. Third question: can arithmetic mean be determined graphically from any of the four options given? None of the options, say histogram, ogive, or pie diagram, can be used to determine graphically the arithmetic mean. So the answer should be option D, which says none of these. Fourth question: for computing the arithmetic mean for a group data, the classes may be, as per the procedure for central tendency evaluation, it is option C. That is, if we go to our PowerPoint presentation, option C, which says any form. Fifth question: if x1, x2, etc., xn are n values with frequency f1, f2, etc. up to fn, then the value of sigma fr into xr minus x bar is. Go back to our worksheet. For every observation xi, there is one x bar in sigma fr into xr minus x bar. Now for n, say n xi terms, that is, there are n observations, each xi, that is, there will be n such terms, then we will have n x bar in the expression, where x bar is nothing but the arithmetic mean of n observations, that is n xi terms, that is x1 plus x2, etc. up to xn by n. Therefore n into x bar is equal to x1 plus x2, etc. up to xn. In our case, sigma fr of xr minus x bar can be written as sigma fr xr minus sigma fr x bar. Sigma fr xr nothing but x1 plus x2 plus x3 up to xn, and sigma fr x bar is nothing but n times your x bar. Now that is also nothing equal to x1 plus x2 plus x3 xn. Already we have x1 plus x2 plus x3 xn subtracted from the same set of sum, we get as 0. Hence the answer is option C. Going back to our PowerPoint presentation, it is option C, which says 0. Moving on to the sixth question: in a frequency distribution, to find the AM, it is the option C, which says the classes sorry, it is the A option, which says frequencies are taken or considered as weights. Uh, this is based on the method of construction of arithmetic mean. So the answer is option A, which is nothing but frequencies are taken as weights. Seventh question, for a set of observation, the median the median need not be one of the given values. This is based on the general definition and use of median, right? So going by our PowerPoint presentation, it is B option, which says need not be one of the given values. Eighth question, if all the observations are distinct, then mode is not defined. That is the definition of mode. So we go into the PowerPoint option answer, which says mode, if all the observations are distinct, then mode is not defined. C is option, it says not defined. Ninth question, in a frequency distribution, mode is given by the formula L plus D1C by D1 plus D2. Please make a correction, it is D1 plus D2. When D1 is the difference of frequency in the modal class, and if you see in our worksheet, where actually the formula is for mode in a frequency distribution is L plus D1C by D1 plus D2, not D1 D2, where D1 is the difference of frequency in the modal class and with the frequency of the preceding class. So hence the answer is option B, which is given in our PowerPoint as B option, or preceding class. B option, it says preceding class. 10th question, in a discrete frequency distribution, mode is that value corresponding, as per definition, is the highest frequency. So the answer as per our PowerPoint presentation, it is B option, which says highest frequency. 11th question, geometric mean for a set of n positive observation is, as per definition, is the nth root of the product of the observation. So the answer is option C, which says the nth root of the product of the observation. 12th question, when x and y are two sets of positive values, then the geometric mean of xy is nothing but geometric mean of x into geometric mean of y. This is based on the properties of geometric mean. Going by our PowerPoint answer, it is B option, says geometric mean of x into geometric mean of y. 13th question, if H1 and H2 are the harmonic mean of N1 and N2 observations, that is the total number of observations in each case, the combined harmonic mean is as per the working. By definition and relationship of harmonic mean and arithmetic mean, we know that if H1 and H2 are the harmonic mean of N1 and N2 observations respectively, then 1 by H1 and 1 by H2 are the arithmetic mean of N1 and N2 observations respectively. Therefore, combined or compound arithmetic mean will be given by the standard formula of the what do you call the n1 times the arithmetic mean of the first one plus n2 times the arithmetic mean of the second one divided by n1 plus n2. That is n1 by h1 plus n2 by h2 divided by n1 plus n2. Hence, combined or compound harmonic mean will be just the reciprocal of the above case. So it will be n1 plus n2 divided by n1 by h1 plus n2 by h2. So the answer is option D. Going to our PowerPoint presentation, it is option D, which says n1 plus n2 by n1 by h1 plus n2 by h2. 14th question, for a set of n positive valued observation, the arithmetic mean will be always greater than or equal to geometric mean, which will be in turn greater than or equal to harmonic mean. So the answer in as per PowerPoint presentation, it is B option, or arithmetic mean is greater than or equal to geometric mean, which is greater than or equal to harmonic mean. This is the general characteristics and properties of arithmetic mean, geometric mean and harmonic mean. 15th question, A, G, H are arithmetic mean, geometric mean and harmonic mean between the positive inequalities A and B. Then we have, as per the property, the relation between arithmetic, geometric and harmonic mean would work out to G squared is equal to A into H. That is, square of the geometric mean will be equal to the product of the arithmetic mean and harmonic mean. So the answer is B option, or G squared is equal to AH as per our PowerPoint projection. I repeat, B option, G squared equal to AH. 16th question, the arithmetic mean of the values 1, 2, 3 etc. up to n with frequencies 1, 2, 3 etc. up to n. Going back to our worksheet, general formula for an arithmetic mean with frequency distribution is given by sigma fx by sigma f. In the problem given, the values or observations are 1, 2, 3 etc. up to n with frequencies 1, 2, 3 etc. n respectively. So sigma fx by sigma f will be equal to sigma, it will be 1 into 1 plus 2 into 2 etc. That is sigma n squared by sigma n. So sigma n squared will be n into n plus 1 into 2n plus 1 by 6, n into n plus 1 by 2. Sigma n is n into n plus 1 by 2, so it works out to 2n plus 1 by 3. Answer is option C. Going to our PowerPoint presentation, the answer is B option, which says 2n plus 1 by 3. 17th question, there are two groups of 10 and 20 items with mean values being 15 and 25 respectively. We need to calculate the combined mean or the compound mean. Going to our work area, there are two groups of 10 and 20 with arithmetic mean values being 15 and 25 respectively. We know that combined arithmetic mean or the compound arithmetic mean is n1 a1 plus n2 a2 by n1 plus n2, which is a general formula, where n1 is the number of observations, n1 and n2 are the number of observations, a1 and a2 are the arithmetic mean. So based on this calculation, we work out and find that it is 65 by 3. So the answer is option A. Going to our PowerPoint presentation, it is option A, which says 65 by 3. 18th problem, if harmonic means of two group of 10 and 20 observations are 10 and 80 respectively, the harmonic mean of the combined group of 30 observations would work out as follows. There are two groups of 10 and 20 observations whose harmonic mean are 10 and 80. The harmonic mean of the combined observations is as follows. We know that the combined harmonic mean, as worked in the earlier problems, is given by the formula n1 plus n2 by n1 by h1 plus n2 by h2, where n1 n2 are the number of observation, h1 and h2 are the harmonic means of the respective observations. Then if you work out, it works out to as 10 plus 20 10 plus 20 by 10 plus 20 by 80, which on simplification gives you the value 24, which is nothing but answer option C. Going to our PowerPoint presentation, it is option C, which is 24. 19th question. The geometric mean of one variable x is 5 and that of another variable is 10. Then the geometric mean of their product is given by as follows. By properties of geometric mean, we have geometric mean of one variable multiplied by geometric mean of another variable will be equal to geometric mean of the product of the two variables, that is 5 into 10, which is 50. So answer is option D. Going to our PowerPoint presentation, it is option D, which says 50. 20th problem. Out of two sets of variables x and y, there exists a linear relationship of the form y equal to 5x minus 10. The median of x is given to be 20. We need to find the median of y. Going to our PowerPoint presentation, the work area, given y is equal to 5x minus 10. Now median of x is given to be 20. Now median of y is equal to median of 5x minus 10, which is now median, which is equal to 5 into median of x, that is 20, minus 10, which is 90. So the answer is option D. And going to our PowerPoint presentation, it is option D, which says 90 is 21. If the two variables x and y are related by y equal to 2x plus 22, given the mode of y is 48, we need to calculate mode of x. Going to our worksheet, given y equal to 2x plus 22, also mode y is 48, then mode of y is mode of 2x plus 22. Now 48 will be equal to 2 times mode of x plus 22, and when we work out on simplification, we get mode of x to be equal to 13. Our answer is option C. Going to our PowerPoint presentation, it is option C, which says 13. 22nd problem. The arithmetic mean and geometric mean for two numbers 9 and 16 are. Going to our work area, the arithmetic mean and geometric mean for two numbers 9 and 16 is as follows. Arithmetic mean is equal to the sum of the two observations, that is 9 plus 16 divided by the number of observations. Here it is 2, so 9 plus 16 by 2 will be equal to 12.5, and geometric mean is nothing but square root of those two observations, 9 and 16, which works out to 12. So the answer is option A. Going to our PowerPoint presentation, it is option A, which says 12.5 and 12. 23rd problem. The mode of the set of values 7, 3, 6, 9, 7, 8, 3, 9, 3, 12, 15, 13 are. Going by the definition of mode, it is the most repeated value. In this sequence of observation, we find that 3 is occurring the maximum number of times. So the mode of this observation, as per definition, will be option B, which says 3. We go to the PowerPoint presentation answer. It is B option, which says it is 3. 24th question. If G1 and G2 are the geometric means of the two sets of values of variable x and y such that x equal to 4y, we would like to know how G1 and G2 are related. Given x equal to 4y, that means for every xi we will get one corresponding y. Suppose we have n xi different terms, then we will have n y1 yi different terms corresponding to every xi. Now we for example, x for every x, for x1 we will have one y1, x2 we will have one y2, x3 will have one y3, etc. xn will have yn. Suppose we take n terms. Now x1 into x2 into x3, etc. up to xn. Now we know x equal to 4y means x1 will be equal to 4y1, x2 we replace it as 4y2, etc. up to 4y1. Now taking nth root on both sides, we will have the nth root of x1, x2, xn equal to nth root of 4. We segregate all the 4's together, which will make it as 4 power n into y1, y2, etc. up to yn. That is, now the nth root of x1, x2, etc. up to xn will give you the geometric mean of x, that is g1, and the nth root of y1, y2, etc. up to y1 will be g2. Now nth root of 4 power n will be 4, so the relation g1 equal to 4g2. Now the option for the answer is B. Going by our PowerPoint presentation, the option is B, which says g1 equal to g2. 25th question. The interquartile range for the following set of observation 17, 6, 12, 21, 19, 18, 24, 26 is going to our work area, arranging in sequence the observation 6, 12, 17, 18, 19, 21, 24, 26. First quartile Q1 is given by n plus 1 by 4, where n is the number of observations. Now we have only 8 observations, so 8 plus 1 by 4, which is 2.25, which means second term plus 0.25 into third term minus second term, which works out to 13.25. Third quartile is Q3, which is 3 by 4 into n plus 1, which is equal to, on working, 6.75, which is sixth term plus 0.75 of seventh term minus sixth term. So interquartile range, sorry, not deviation, it is range, is equal to Q3 minus Q1, so which we find it out as 23.25 minus 13.25, which is equal to 10. So it is option B. Going to our PowerPoint presentation, it is option B, so the answer is 10. 26th question. A relative measure of dispersion is always an unit-free measure. Based on the 4 option given, it is the B option, which says an unit-free measure. So B is option, answer is an unit-free measure. 27 question. Quartile deviation is affected only by change of scale. So out of the 4 options provided, it is the B option, which says only by change of scale. This is the standard characteristics and property of quartile deviation. Standard deviation has the same unit of measurement as that of observation. Out of the 4 options, if you see, the option B, which says has the unit of measurement same as that of observation, is correct. This is as per the property and the definition of standard deviation. Now mean deviation is nothing but the arithmetic mean of the absolute deviation of all the observations from their mean. That is sigma of xi minus x bar, that is arithmetic mean, divided by the total number of observation. So it is the B option as per PowerPoint presentation, which says the arithmetic mean, the mean deviation is the arithmetic mean of the absolute deviation, that is x, a modulus of xi minus x bar, that is arithmetic mean of all the observation from their mean. So B is option. So it is mean deviation is, again I repeat, the arithmetic mean of the absolute deviation of all the observation from their mean. 30th question. Mean deviation is applicable is based on all observations made. So it is the A option, or as per PowerPoint, A option, which says based on all observations. 31st question. All the measures of dispersions are not affected by change of origin but affected by change of scale. Uh, the As per the PowerPoint presentation solution, it is C option, which says again unaffected by change of origin but affected by change of scale. Unaffected by change of origin but affected by change of scale. That is C option. 32nd problem. A relative measure of dispersions are used to compare the variability with values of two different sets. It is by definition relative measures of dispersion is the answer. So it is option A, which says compare the variability with values of two different sets. 33rd problem. The measure of average and dispersion suitable to obtain the same for probable measures after counting two or more groups is given by mean, standard deviation, which is based on the definition and characteristics of standard deviation. So as per PowerPoint presentation, it is D option, which is mean, standard deviation. 34th, standard deviation is also called as root mean, square root of the mean of the square of deviation above the mean. So going by the PowerPoint presentation, it is C option, which says root mean square deviation above the mean. 35th question. If the mean and standard deviation of set of 20 observations are 16 and 25, the mean and standard deviation of x minus 16 by 5 is worked out in the worksheet as follows. Mean of x minus 16 by 5 is nothing but expectation of x minus 16 by 5, which is expectation of x minus 16 by 5. Expectation of x is nothing but mean, which is of x, which is given to be 16. So substituting, we get mean of x minus 16 by 5 will be equal to 16 minus 16 by 5, which is 0. Now we all know that variance is standard deviation squared. So variance of x minus 16 by 5 will be nothing but variance of x divided by 5 squared, that is 25, and that is equal to variance of x is nothing but standard deviation squared divided by that 25. So we know that standard deviation of x is given to be 25. So 25 into 25 by 25 will be the variance of x minus 16 by 5. But what we require is standard deviation of x minus 16 by 5. So that is nothing but root of 25, which is 5. So the answer is option A, which is 0, 5. Going to our PowerPoint presentation, it is option A, which says 0, 5. That is the mean and standard deviation of x minus 16 by 5, given that mean and standard deviation of set of 20 observations are 16 and 25. So the option A, 0, 5. 36th question. If x and y are variables related by 2x plus 5 minus 12 equal to 0 and the range of x is 15, the range of y is computed as follows. Given 2x plus 5y minus 12 equal to 0, range of x equal to 15, y can be rewritten as 12 minus 2x by 5. Now range of y is equal to range of 12 minus 2x by 5, which is equal to absolute or modulus of minus 2 by 5 into range of x, which is equal to 2 by 5 into 15. The range of x is given to be 15, so the value is 6. So the answer option is D. Going to our PowerPoint presentation, it is D, which says the answer is 6. 37th problem. If the variance of x is 15, the variance of 7 minus 2x need to be computed. It's given that variance of x is 15 and we have to find the variance of 7 minus 2x. We know that in general variance of b minus ax is equal to a squared variance of x. Now variance of 7 minus 2x is equal to 2 squared of variance of x, which is equal to 4 into variance of x is given to be 15, so 4 into 15 is 60. So the answer is option B. Going to our PowerPoint presentation, B is the option. The answer is 60. 38th problem. The quartile coefficient of distribution where the quartiles are 20, 52 and 80 has to be computed. Going to our work area. Now quartile coefficient of distribution is given by Q3 minus Q1 by Q3 plus Q1 into 100. Now our Q1 here will be the first quartile, that is 20, and Q3 is our third quartile. So the coefficient Q3 minus Q1 by Q3 plus Q1 into 100, called the quartile coefficient of distribution, works out after substituting the relevant things as 60. So the answer is option D. So going to our PowerPoint presentation, it is D option, which is says it is 60. If this 39th problem, if the standard deviation of first n natural numbers is 2, then we need to calculate the value of n. Alt tab. Standard deviation of first n natural numbers or n consecutive natural numbers is given by the formula root of square root of n squared minus 1 by 12. Applying that, we can solve for n. Given standard deviation of first n natural numbers to be 2, so that is equal to square root of n squared minus 1 by 12. On simplification, we get the value n equal to plus or minus 7. But n being a natural number, n takes the value plus 7 only. So the answer is option A. Going to our PowerPoint presentation, it is option A. It says the value is 7 for n. 40th problem. The standard deviation of the values 5, 5, 5, 9, 9, 9, 10, 10, 10 is worked out as follows. Putting it into the tabular form as shown, the observation x, f, fx, d squared and fd squared. Now x, actually 5 repeats 3 times, 9 repeats 3 times, 10 repeats 3 times. So fx will be 15, 27, 30. When you add up 72, so x bar is sigma fx by sigma f, which is 8. Now d is the deviation from the arithmetic mean, that is x minus x bar, which is x bar is 8, x is 5 means minus 3, 9 it is 1, and from 10 it is 2. So d squared would work out to 9, 1, 4, fd squared 27, 3 and 12. So standard deviation is given by square root of sigma fd squared by sigma f, which is square root of 42 by 9, which is square root of 42 by 3. So the answer is option B. Going to our PowerPoint presentation, it is option B. It says square root of 42 by 3. 41st problem. The quartile deviation of the following data we need to compute. Going to our work area, x is written under x you have the data, that is 2, 3, 4, 5, 6. F, the frequency 3, 4, 8, 4, 1. So the total frequency is 20. So your n here will be 20. So 20 plus 1, So when you try to calculate the first quartile Q1, you will get 5.25. that is the fifth term here is value is 3 plus 0.25 into sixth term minus fifth term. Sixth term and fifth term being 3, so the difference will be 0, so Q1 will be 3. On the same lines, 3/4 of n plus 1, which is the third quartile, works out to be 15.75, and 15th term value is 4 plus 0.75 into 16th term minus 15th term. 16th term is 5, 15th term is 4, so it is 0.75 into 5 minus 4 is so the third quartile is 4.75. So Q3 minus Q1 by 2 is the quartile deviation, which works out to 7 by 8. So it is option C. Going to our PowerPoint presentation, it is option C, which says 7 by 8. 42nd problem. If the standard deviation of three independent variables x, y, z are sigma, then the standard deviation of y plus z, z plus x, and x plus y needs to be evaluated. Going back to our work area, the general standard deviation of x, y, z is given to be sigma, and mean would be x plus y plus z by 3. Standard deviation general formula is square root of x minus x bar by n. So you replace the relevant things, and finally we get it as square root of 1 by 3 into 2x minus y minus z by 3 whole squared plus 2y minus x minus z by 3 whole squared plus 2z minus x minus y by 3 whole squared, which is equal to sigma. Now mean of x plus y, y plus z, and z plus x is equal to twice of x plus y plus z by 3. Standard deviation of x plus y, y plus z, and z plus x. This set of variables observation would work out to be like this, and on simplification we get square root of 1 by 3 into x plus y minus 2z by 3 whole squared, etc. And since this expression, each expression is a square, so whether it is x plus y minus 2z by 3 whole squared or 2z minus x minus y by 3 whole squared will be the same. Hence we find the two of them have the same standard deviation sigma. That is, both have the same standard deviation sigma. So the answer is option A. Going to our PowerPoint presentation, option A, which says sigma. 43rd problem. If the standard deviation of the set of values 7, 3, 4, 5, 6 is k, then the standard deviation of set of values 9, 12, 15, 21 is to be computed. Now sequentially arranging the set of values, standard deviation of this set, say 3, 4, 5, 6 and 7, the sequence is given to be k. Therefore standard deviation of 9, 12, 15, 18, 21 is to be found. This set is 3 times the previous set of values. As we know, dispersion is affected only by scaling factor. Therefore standard deviation of the second set of observation is 3k, 3 times the previous standard deviation, or 3k. So the option is C. Going to our PowerPoint presentation, option C is the answer. It says 3k. So 44th question. If all the observations are multiplied by 3, out of the 4 options, D is the correct answer, because all other statements are wrong. Because when you multiply by 3 the observation, standard deviation will get changed, mean will also get changed, variance will also get changed. Whereas the D option says coefficient of variation is unchanged, because coefficient of variation is standard deviation by arithmetic mean into 100. Standard deviation changes by 3 times, and mean also changes by 3 times if it is multiplied. but the net coefficient of variation will not change. So the answer is D option, which says coefficient of variation is unchanged. So it is D option. Coefficient of variation is unchanged. 45th problem. If two variables are connected by the relation 3x plus 5y minus 12 equal to 0, the mean deviation of x is 15, then we need to calculate the mean deviation of y. Going to our work area, y is equal to 12 minus 3x by 5. Given mean deviation of x is 15, then mean deviation of y is mean deviation of 12 minus 3x by 5, which is nothing but absolute value of minus 3 by 5 into mean deviation of x. That is equal to 3 by 5 into 15 equal to 9. So it is option B. Going to our PowerPoint presentation, it is option B, which says 9. That is B option, which is 9. 46th problem. If the sum of the quartiles Q1 and Q3 is 30 and quartile coefficient of deviation is 15, then the difference of quartiles. Going to our work area, Q1 plus Q3 is 30. Quartile coefficient of deviation is given by Q3 minus Q1 by Q3 plus Q1 into 100 equal to 15. Then difference of quartiles or range is Q3 minus Q1, which is equal to Q3 plus Q1 into 15 by 100 equal to 15 by 100 into 30, that is 4.5. Our answer is option C. Going to our PowerPoint presentation, it is answer is option C, which is 4.5. 47th problem. If x and y are related by 2x plus 3y minus 7 equal to 0 and the mean and mean deviation of x are 1 and 0.3 respectively, the coefficient of mean deviation of y needs to be computed. Going to our work area, mean of x is 1 and mean deviation is 0.3. Now given the equation 2x plus 3y minus 7 equal to 0, we can rewrite this as y equal to 7 minus 2x by 3. Now mean of y is mean of 7 minus 2x by 3, which is on evaluation we get as 5 by 3. Now mean deviation of y is equal to mean deviation of 7 minus 2x by 3, which is absolute value of minus 2 by 3 into mean deviation of x, which works out to 0.2. Now coefficient of mean deviation is mean deviation by arithmetic mean into 100. Now mean deviation is 0.2, arithmetic mean or the mean is 5 by 3, multiplied by 100 you work out as 12. So the answer is option B. Going to our PowerPoint presentation, it is option B, which says it is 12. 48. If all the observations are equal to 40, then the coefficient of quartile deviation is to be computed. Going to our work area, since all observations are equal, there is no deviation, or Q3 minus Q1 is 0. Therefore, coefficient of quartile deviation is given by Q3 minus Q1 by Q3 plus Q1 into 100 is also 0. Hence, the answer option is B. Going to our PowerPoint presentation, the answer is B option, which says it is equal to 0. 49th question. In this case of positive distinct quantities, mean deviation is minimum when the deviations are taken from median. Actually, it is the property of mean deviation definition and the characteristics of median. The mean deviation with respect to median. So the answer is B option, or median. So B option, which says median. 50th question. Standard deviation of two observations A and B. Using the formula for SD, we get as half of either A minus B or B minus A, because standard deviation is always positive. So in general we can write it as half of modulus of A minus B, which says it is B option. using the formula of standard deviation, and standard deviation needs to be positive also. So the final answer is B option, or half of mod A minus B. Thank you for your patient hearing on the topic measures of central tendencies and measures of dispersions. For any further doubts and queries, please email to queries@greymatteracademics.com. Thank you. See you later. Bye bye.